In data analysis, data types play a fundamental role in organizing and making sense of the vast amount of information we encounter daily. They help us classify and analyze data, enabling us to draw meaningful insights and make informed decisions. Hi, I'm Aline from the Experience Research Lab. Today I want to talk about data types. Generally speaking, data fall into two main categories, qualitative and quantitative data. But before I going any further, I would like to recommend you watch the previous video regarding qualitative and quantitative research. In the video, I said that in qualitative research, which aims to generate contextually rich data to uncover nuanced understanding of phenomena, data collection often involves open-ended interviews, focus groups, observations, or content analysis of text, images, or videos. Particularly during data analysis, qualitative research relies on manual coding and categorization, and therefore it sometimes also comes with numbers that may confuse some. Are they qualitative or quantitative? So qualitative data is also known as categorical data. It represents distinct categories or labels used to group and classify items or observations. Some of the examples are gender, marital status, eye color, types of vehicles, educational level, etc. etc. So when coded, qualitative or categorical data like this might look like quantitative data. Well, however, they are not mathematically measurables because they lack a natural order or numerical value. There are two subtypes of qualitative or categorical data. They are nominal and ordinal. So nominal data represents categories with no inherent order or ranking. These categories are solely for classification purposes in various fields such as marketing or biology. They don't possess any quantitative value. All the examples I mentioned previously, such as gender, male, female, or non-binary, marital status, married, single, divorced, eye color, brown, blue, green, etc., animal species, dog, cats, horse, and types of vehicles such as sedans, SUV, and truck are all nominal data. So as a researcher or interviewer, you may speak with the male participant and code him as 1. Later, when you notice the participant is a female, you may code 2. And when someone advises you not to identify them as either, you may code 3 for non-binary. Code 1 that you assign to the male is not any higher or lower than code 2 that you assign to the female. Therefore, you can change the code to female as 1 and male as 2 and non-binary as 3. And when you do so, it doesn't have a valuable impact other than changing the category itself. By the way, nominal data has two subtypes, binary and non-binary. As a subset of nominal data, binary data consists of only two categories, typically denoted as 0 and 1. It is frequently used in fields like computer science for Boolean values or in medical studies to indicate the presence or absence of a medical condition. Some of the examples that you might have often heard are yes or no, where you denote 0 for no and 1 for yes. Win or lose, true or false, pass or fail, and hit or miss. Non-binary categorical data comprises categories with more than two distinct values that lack natural orders. And once again, all the examples I mentioned in the beginning of these videos are all categorical data, and they are non-binary because they have more than two categories. Ordinal data represents categories with a specific order of ranking but unequal intervals between them. It reflects relative differences in magnitude but doesn't provide precise quantitative values. While we can establish a rank, we cannot quantify the exact difference between these categories. For example, in a family, a father or mother may code their first kid as 1, the second one as 2, and the third one as 3, and so on and so forth. While it does let us know the order, it doesn't tell us exactly how many years they are different from each other in terms of age, The first kid can be 1 year older than the second one, while the second one can be 2 years or even 12 years older than the third one. So we don't know the exact difference. So in any race, in the world of academic, business, or sports, we know there's always a champion or a winner, runner-up, or someone else in the third place. But again, we don't always have a clue about the difference between them in terms of score, size of customer base, and time record to get to the finish line. The first rank at school may have an average score of 95, while the runner-up and the third place only have 90 and 80 respectively. As a market leader, a company A may serve millions of customers, while the other two only do hundreds of thousands of customers. Zhang Yuwei only needed 2 minutes and 7.99 seconds to finish the 200-meter butterfly race. But even such a fantastic record only led her to the third place after Airi Mitsui and Hiroko Makino. And believe it or not, the difference between the first, second, and the third was only less than a second. Very, very little difference. Another example of ordinal data is the Likert scale used to indicate agreement, importance, likelihood, and quality. In a survey, you may quote such a level of agreement from 1 strongly disagree to 10 strongly agree, 1 unimportant to 5 important, or 1 to very unlikely, and 3 very likely. However you do it, the code only gives you a glimpse of magnitude without any details such as how different the views between those who strongly disagree and those who strongly agree, or those who say it is very unimportant and those who say it is very important. And therefore, the deliverables in qualitative research always include detailed narrative reports, case studies, or thick descriptions of findings that provide rich insight into the research topic. Often they even come with direct quotes from their participants just to give you a context and more explanations on why and how things happen behind a certain phenomena. I think that's all I can share with you today. Thank you for being with me. If you want to learn more about data, please do subscribe to this channel, because right after this video, I'll be sharing more about quantitative data. See you there, and cheers.